So in this video, we're looking at the upper and lower Riemann sum. And this is one of the, this is kind of that analogous to finding the derivative with the limit definition. Okay, so we're not going to do everything in math like this from now on to the end of time. But this concept, what we're doing with the upper and lower Riemann sum, is going to be foundational to what you do at the beginning of Calculus 2 when you find the volume of solids of revolution and other concepts like that. So what I want to do is make sure in this video that you understand more conceptually what we're trying to do. And I'm going to show you a few graphs and kind of talk you through what you're seeing so that you can have an idea of really what it is the Riemann sum is telling us. Okay, so we'll do a few of these. We'll find an upper and lower sum. We'll determine if the sum is going to be an overestimate or an underestimate, and then that'll prep you for what you're going to see in the Newton homework assignments. Now, this screen right here, you can take a look at and read through if you'd like. But what I really want to do is focus on this first example here. Okay, so when I find the lower and upper sum for f of x equal 10 minus x squared on the interval from 1 to 2 with 4 subintervals, there are a couple of things I have to remember. Okay, so that's what this first example is wanting us to do. Find the upper and lower sum for f of x equal 10 minus x squared on this given interval 1 to 2. So there's something really important going on here. We said that we want 4 subintervals. So what that means is between the intervals of 1 and 2, between the x values of 1 and 2, I want to break that up so that I have 4 rectangles. Okay, so that's what we mean by 4 subintervals, the number of rectangles. So we're going to go and we're going to have our y-axis and our x-axis, and then 10 minus x squared is a parabola that's been moved up 10 places and it opens down. So it's more of a frowny face. And we're only looking for the piece of that parabola that exists between the x values of 1 and 2. So you can imagine that if I plug 1 in for x, I get 9. And if you plug 2 in for x, you're going to wind up with 6 because 10 minus 4, right, is 6. So I have those y values, but what's more important and where we want to focus on is what are we getting when we break this thing up into those 4 subintervals. So I've got a mark here, here, and here. So I took those x values 1 and 2, and I broke that up into 4 equal parts. Okay. And that allows me to find out what those subintervals are going to look like. Okay, so just graphically, now what we have is this frowny face, this upside down, and I've got this thing broken up into 4 equal, 4 rectangles with equal width. Okay, so if I wanted to find the area, right, then I would need to go in and define, am I looking for an upper sum or a lower sum? And so if I'm looking for an upper sum, what I want to do is take a look at rectangle 1, and I want to choose the height of that rectangle so that it's determined by the bigger y value. Okay, and on the next screen, we take a look at this in a little more in depth. Okay, now the first thing we want to do is we want to remember that to find the area of a rectangle, we're going to use the formula base times the height. The base in our problem is going to be whatever that width is between each of those x values. So we said that we're going to have the interval from 2 to 1, and they're going to be 4 rectangles. So to find out the width of each rectangle, I'm going to subtract 1 from 2, and I get 1. And I'm going to divide it by the number of subintervals, 4. So each rectangle has a width of 1/4. Okay, let's take a look at that next slide here. So this is a little better picture, and we can zoom in on that if you like. So we can zoom in and see kind of what's going on here. What we've illustrated on this slide here is a lower sum, and so we've chosen the height of the rectangle to be determined by the smaller of the two y values. Well, if I choose an upper sum, then I'm going to go and let my rectangle look like this, right? So you can see that upper sum chooses the bigger height and the lower sum uses the lower height. All right. Now, the other thing that we want to keep in mind is when we're looking at, when we're talking about the height of our rectangle, right? What determines the height of that rectangle? Well, if you look at rectangle 1 right here, the height of that rectangle is determined by the y value at x sub 1. And then the height of the next rectangle is determined by the y value at x sub 2. And then at x sub 3 and x sub 4. So the question then becomes is, well, what does x sub 1 equal? If you recall, we started our intervals at 1, and the width of each interval was 1/4 or 0.25. So this x sub 1 is going to be 1.25, and x sub 2 is going to be 1.5. X sub 3 is 1.75, and then x sub 4 is that last y value or x value, which is 2. So notice what we have as our Riemann sum. We've got the sum, right? That's sigma, the sum from I equal 1 to 4 of 1/4, right? So this is delta x times f of x sub I. So if you look at this, f x sub I delta x, fx sub I is the height of the rectangle and delta x is the base of the rectangle. So we're going to add the 1/4, we're going to add the areas of all these rectangles, okay? So to find the height of each rectangle, I'm going to plug in 1.25 to this original function. And you can see that down here. And then I'm going to plug in 1.5 to the original function, and there it is. Same thing for 1.75 and 2. Now, if you notice with what you see here, you only have 1/4. You can think of it like this: the area of the first rectangle, the area of the second rectangle, the area of the third and fourth rectangles. So if I'm finding the area of each rectangle, it's going to be 1/4 times the function height at that x value, and another 1/4 times the function height at the second x value. So what's happening is on the PowerPoint, they're factoring out this 1/4, so you only have that 1/4 value to deal with. So if I plug in 1.25 and square it, subtract 10, right? We can use our calculator to do that. Give me just a moment. I'm pulling mine up here, and you can follow me through these calculations. So 1.25 squared gives me 1.5625. I'm going to subtract that from 10, and I get 8.4375. Now, what the PowerPoint has done is it's gone in and said, okay, this first height is 8.4375. If you wanted to do this problem like this, where you're finding each area and just adding them together, we would take that value and multiply by 0.25. So my first area turns out to be 2.109. I'm going to do the same thing for this next value, 1.5 squared. I'm going to subtract that from 10. I get 7.75, and I'm going to multiply that by 0.25. For me, this next area turns out to be 1.9375. So you can round a little bit. I wouldn't round to 2, right? I would keep 3 or 4 decimal places just for accuracy's sake. That next value is going to be 1.75, and I'm going to square that, subtract it from 10, and then I'm going to multiply by 0.25. That third area is 1.7344. Okay, I'll round out here to the 4th or 5th decimal place, but I don't want to round too quickly. This last one here is going to be 10 minus 4, which we said was 6, and we're going to divide 6 by 4. That last area is 1.5. Now, if I add all these values up, I'm going to have 1.9375, right? So I've added the first 3. I'm going to add in that last one plus 2.109. My estimate comes to 7.2809, which is really, really close to what we got right here, right? 7.28. Okay, so again, really, it's a matter of finding the area of each of these rectangles. And what's important to remember is that when we're finding the area of that rectangle, the width here, delta x, is what we get when we find that subinterval. Now, this one was a lower sum, okay? In the next example, we're going to do this, we're going to redo this where we find the upper sum. So let's zoom in and take a look at what numbers we're using and why we're using those numbers. So in the PowerPoint, instead of listing 1/4 times some height and 1/4 times another height and 1/4, Newton says, you know what, I'm just going to factor that 1/4 out. I'm going to add up all the heights and then multiply by 1/4 in the end, which is perfectly fine. You saw in the last example that we get the same answer. So here, let's talk about why this number is 1, 1.25, 1.5, and 1.75. Let's talk about why we don't use 2 in this problem. Notice how when I draw the rectangles, it goes beyond the actual curve. We call this an upper sum because we're letting the height of this rectangle be determined by the greater of the two y values. So when I'm looking at this, I have this coordinate and this coordinate. I'm going to choose the left side to be the upper sum. Okay, but again, because that rectangle goes outside of the actual curve. So that's why we're using 1, 1.25. So we're going to use 1. This x value will beat the one right here on the right because it's taller. So the next x value is 1.25, and then 1.5 and 1.75. Let's look at one where we don't necessarily have that picture off the top of our head to go by. So here we have find the lower and upper sums for 8 minus x to the third. Similar interval and subinterval, 1 to 2 with n equal 4 subintervals. So remember how we went to find the area of each, or the width of each of those rectangles? We subtract those values and divide by 4, right? So in this problem, the width of each rectangle is 0.25. So if I wanted to find area 1, I would have 1/4 or 0.25. All right, so I'm going to have 1/4 here, and area 2 is going to be 1/4. Area 3 is 1/4. Area 4 is 1/4. Now I have to go figure out, okay, am I going to multiply by this set of numbers? Am I going to start by plugging 1 in and finishing with 1.75, right? Do I use the first 4 numbers, or do I use the last 4 numbers? So here's one way to figure that out. If I plug 1 in for x, I'm going to have 8 minus 1, which is 7. Well, let's figure out what we would get if I plugged in 1.25. So I'm going to cube 1.25, right? 1.25 cubed. And I'm going to subtract that from 8. And you'll notice that this value at 1.25 is 6.05, and this one at 1 is 7. So if I'm finding an upper sum, I want to use the bigger of these two values. Okay, so it turns out that as you go throughout, right, as you go this way, the value is going to decrease. Okay, so to find the upper sum, we're going to start with 1 and then choose 1.25, 1.5, and 1.75. You can see how that's played out here. And the width of each of those rectangles is 1/4. And the lower sum will start with 1.25 and then go 1.5, 1.75, and 2. So if you were to take a minute and look at the graph of this thing, right? What does the graph of 8 minus x to the third look like? Well, let's create us a new window. And I'm going to go to one of my favorite websites. Okay, so this is Desmos, and I'm just going to do 8 minus x to the third power. And you can see that between 1 and 2, this thing is decreasing, right? You can see that it's kind of a half of a frowny face there, much like the problem that we just finished doing. Okay, here's a trig function, and this one's a little different because we're going from 0 to pi over 2 with 3 subintervals. So this would be a good problem for us to look at just to get you ready for what you may see in the Newton homework. I'm going to go over here in the blue area, and I'm just going to graph what sine of x would look like from 0 to pi over 2. You'll recall that sine starts at 0 and goes up to 1. Okay, so sine does this thing right here, and then after pi over 2, it comes back down and goes below, but we're not interested in any of that. We're only interested in the region from 0 to pi over 2. So let me get this back up here. Okay. And so here's pi over 2. And I want to break this up into 3 subintervals. Okay, so I'm going to have a total of 3 rectangles. My job is to figure out what values are we going to use. So we're going to start with 0 because that was given to us. And we're going to end with pi over 2 because that was given to us. And if I do pi over 2 divided by 3, right? So to find the width of each rectangle, I have to do pi over 2 minus 0 divided by 3. The width of each rectangle turns out to be pi over 6. So this first rectangle is going to be at pi over 6, pi over 3, and pi over 2. Those are the values, the x values I'm going to use. Now we're going to start, right? It says find the lower and upper. So we'll start with the lower sum and then go to the upper sum. So to find the lower sum, I'm going to take what I know right here in this first rectangle. The lower y value is here at 0. So I'm going to use that as the first height. I'm going to use 0 as the first function value, or the first x value. And then I'm going to use pi over 6 and pi over 3. Now remember, this is for a lower sum. Okay, so the lower sum is this one right here, the lower sum. And you'll notice we start with the sine of 0, the sine of pi over 6, and the sine of pi over 3. And these are decimal values, so you can use your calculator, right? The sine of 0 is 0. To do the sine of pi over 6, let me pull up the calculator here on my computer so that you can see how I'm doing this. I had my mind went blank. There it is. Couldn't find my calculator. Okay. So I'm going to do the sine of pi over 6. Well, I need to be in radians. I'm going to do pi divided by 6. Pi divided by 6. I'm going to take the sine of that, right? So it's 0.5. So I have 0 here. I have 0.5 plus, I've got to do the sine of pi over 3. So I'm going to go back. I'm in radians. I'm going to do pi divided by 3 and take the sine of that. Right, so 0.866. So I'm going to add these two together and multiply by pi over 6. Okay, so it'll look like this. I'm going to add 0.5. I'm going to multiply by pi and divide by 6. And so we get 0.715, right? There's our lower sum, 0.715. And we'll repeat the process to do the upper sum, but there is a bit of a difference. With the upper sum, we're going to use what's on the right-hand side, right? We're going to use the bigger y value to find our rectangles, right? So we'll use that one, and that one. The upper sum will always be an overestimate. The lower sum will always be an underestimate. That's going to be something that you might see when you get into your Newton homework. It says, consider the previous example. We found the lower and upper sums with n equal 4 subintervals, which is the underestimate, which is the overestimate. So, right, you can imagine the lower sum is going to be the underestimate, upper sum is the overestimate. So just keep those in mind as you're going throughout the homework here. The next steps obviously are going to be to get in Newton and do those homework assignments. You can print out the PowerPoint that we just went through. And as always, you can let me know if you have questions. Give me some feedback on what I can do to make our videos better, to make sure you're ready to go in and get to work through the Newton problems.